This new research introduces LQ-LoRa. LQ-LoRa is a method for efficient adaptation of pre-trained language models like RoBERTa and LLaMA-2. This method combines low-rank matrix decomposition with quantized components, which enables us for memory-efficient model fine-tuning. The thing which really sets it apart from the other methods is the ability to dynamically set quantization parameters. These quantization parameters include things like bit width, block size, and a lot of other things per matrix. This really improves the overall memory consumption. This method has already shown that it outperforms existing approaches like QLoRa and GPT-QLoRa, especially in aggressive quantization scenarios. The real problem which this new technique is trying to solve is to reduce the memory footprint of LLMs during fine-tuning without significantly losing performance and quality. Traditional methods often lead to high memory requirements, limiting their practical use, and that is where this LQ-LoRa helps out. They also have a very nice and very efficiently written GitHub repo which can be used to install and use this LQ-LoRa. In order to install it, all you need to do is to git clone this repository and then install the requirements. Once that's done, you need to download whatever data you have for quantization, and it depends upon your model of course. And then this code is used to apply your model quantization. So if you look at this code, it's very simple. All we are doing it, we are importing some libraries, we are applying some of the parameters which I just mentioned, which and these are the quantization parameter and few other things of course. And once that's done, you are specifying your model. In this case we are specifying llama 2 and you can select your model size. In this case it is 70 billion. You can even use 7 billion one. From there we are using LoRa components as a numrac, LoRa alpha and all that stuff. Once that's done, you can apply the model LQ LoRa to this model, and that will enable you to reduce the size while maintaining the um, performance and quality of this model. So this LQ LoRa, it decomposes each matrix into a high precision, low rank part and a fixed quantized component. It uses an integer linear programming approach for the quantization process. This method includes a data-aware version utilizing the Fisher information matrix for better decomposition. The snippet which you see on your screen is from their paper, and you can access it by going to this abstract and clicking on download PDF, and then it will open this page. Now I'll drop the link to this in video description too. So if you look at this comparison, the results are really very impressive. LQ-LoRa achieved notable results like compressing Llama to 70 billion to 2.85 bits with minimal performance loss. For instance, on Open Assistant benchmark, which is a 2.5-bit Llama 2 model trained with LQ-LoRa, matched the performance of a 4-bit model trained with QLoRa. And the 2.75-bit Llama 2 70 billion model, requiring 27 gig of GPU memory, was competitive with the original full precision model. This demonstrates LQ-LoRa's effectiveness in reducing memory requirements while maintaining model performance. So if you are looking to quantize your llama model, I would highly suggest giving this LQ-LoRa a try. And you already know how to do it as I showed you in the GitHub repo. Commands which are very simple. That's it guys. I hope that you enjoyed it. If you are still struggling or stuck, let me know and I will also do a demo on it as how to do it. And if you have any questions, please ask them in the comments. And if you like the content, please consider subscribing to the channel. Thank you very much.